Here we see the design validation tools within SOLIDWORKS. We have simulation, flow simulation, and plastics. And this suite of tools is designed to enable you to cut back and nearly eliminate physical prototypes because you can do all the virtual prototyping within SOLIDWORKS using these tools. And we'll take a look at each one of them individually to showcase their different capabilities. And we'll start with simulation. SOLIDWORKS Simulation is the FEA tool, and it comes in 3 flavors: Simulation Standard, Simulation Professional, Simulation Premium. Now, this is your virtual prototyping tool for structural analysis. So let's take a look at all of the features found in these 3 flavors of SOLIDWORKS Simulation. You have Simulation Standard, Professional, and Premium. Typical naming convention for the SOLIDWORKS tools. So Standard, Pro, Premium. SOLIDWORKS Standard is your static analysis for assemblies, which is a step up from using SimExpress, which is just single body parts. You have your fatigue analysis, motion analysis, and trend tracker. Now, fatigue analysis is designing for the life of the product. You can find out exactly how many cycles it takes for a potential design failure of your part in the field. Motion, it's a lot more than just animation. It's actual motion analysis. So you're understanding things like forces, motors, accelerations, powers involved in moving components, right? And then you have trend tracker. The trend tracker is a feature that allows you to track how things change through various iterations. And then it actually captures save points of each iteration. So you can always roll back to a part in a past point in time. Okay, so those are the things found in Simulation Standard. Simulation Professional includes all of those things in Sim Standard, but then the addition of a lot more capabilities. So let's take a look at these. You have the Materiality Web Portal, which is a database of thousands and thousands of material properties that you can use in your analysis. Frequency analysis, this could also be called modal analysis or natural frequency analysis. So we can understand resonant frequencies in your design. Buckling is buckling a potential manufacturing defect or a point of failure for your design, so you can understand that. You have thermal analysis. So here you can understand how heat moves through your design. Now in Simulation Standard, you can figure out thermal stresses, but in Simulation Professional, you can actually calculate things like temperatures or the power, the heat power, and how heat is transferred throughout your model. Optimization, this automates the design process where you can specify parameters, give them a range, a minimum, a maximum, and let SOLIDWORKS calculate based on a goal. Do you want to minimize the mass while maintaining certain criteria like stresses below a certain value or a minimum factor of safety? You can check for welds and bolts automatically using Simulation Professional. And then you can also do things like drop tests, dropping it from a certain height or at a certain speed. And then you have pressure vessel using the ASME code to understand if you're designing pressure vessels. Event-based motion, now that takes your motion analysis and then adds things like proximity sensors, if-then statements, things like that. And then we get to the last 3, which are simplification and time-saving tools. So 2D simplification is one of my favorite features. I use it every single time I can. It basically takes a 2D section, whether it's a revolve or an extrude, and if applicable, it's a huge time saver. Submodeling, it allows you to run a very coarse, large analysis and then really zoom in on a particular area while also capturing all the effects of that large study. It uses a technique that allows you to zoom in on areas without sacrificing accuracy of the whole model. And then the load case manager. If you're running various scenarios, you can quickly run A, B, C, and D different scenarios while varying certain things. It's a very, very easy way to set up multiple studies and look at the results. And that's Sim Professional. Now, Sim Premium includes everything from Pro and Standard with the addition of these features here. You have your nonlinear material models, whether that's nonlinear elastic or nonlinear plastic, right? So we can talk about post-yield behavior of our materials, nonlinear boundary conditions. Maybe something is, suddenly applied or applied over time. And then we get into dynamic studies. Okay, we have the time history, harmonic, random vibration, and shock response spectra. Right? These are all dynamic studies, and taking the frequency from Simulation Professional and expanding on that, not just resonant frequencies, but actually seeing how these frequencies and vibrations affect the model via stresses and displacements. And then you also get the addition of composite. So you're doing fiberglass or a carbon fiber layups here. You can do that analysis in Simulation Premium. All right, so this is the FEA or structural tool called SOLIDWORKS Simulation. Comes in 3 flavors, again, standard, pro, and premium. So now let's move over to the CFD tool, or the computational fluid dynamics tool, flow simulation. Flow simulation is a lot easier to talk about because it basically has one general tool, flow simulation, to capture all things for fluid flow, fluid dynamics, a much more accurate heat transfer than what's in Simulation Professional, a much more robust heat transfer tool. And then you can also add on certain layers like electronics cooling or HVAC. So let's take a look at this. So here's what it looks like. Flow simulation is essentially everything that a lot of people will need to do. Internal and external studies, flowing through things, pipes or valves, or around things, external flow. You then have both laminar and turbulent flow. You can talk about heat transfer, how much heat is transferred from this solid, this chip, to the air, and how is a fan affecting the heat transfer of my electronics cooling box or a server rack or this room. Rotating regions, non-Newtonian fluids, both steady state and transient. You can take a flow simulation and then send those results over to SOLIDWORKS simulation, where you can do a thermal stress analysis, or you can do, say you have wind blowing on something and you want to understand how much stress is happening due to that wind or that pressure loading. You can exchange the results between flow and simulation and understand both fluid effects and structural effects, and both compressible and non-compressible fluids. So that's regular flow simulation, pretty much everything that a lot of people need to do. And then you have 2 modules that you can add on to it to add to the capabilities. So you have electronics cooling and HVAC. Electronics cooling includes things like joule heating, heat pipes, a more accurate PCB layup for the materials, and then extended database that includes a lot of things that people designing electronics boxes might need to know. And then same thing with HVAC. You have this for advanced radiation, tracer studies, and comfort parameters, and again, an extended database there. But like I said, a bulk of our clients use SOLIDWORKS flow simulation without the addition of electronics cooling and HVAC. If it's something that you think you might need, you probably will know that you need it, right? Those things like joule heating and heat pipe or comfort parameters and advanced radiation, those mean something to you. And if they really don't mean anything to you, then flow simulation is probably all you need. All right, so that's the computational fluid dynamics tool, CFD tool, our flow simulation tool. And then we move over to the injection molding analysis tool, SOLIDWORKS Plastics. So again, using that typical SOLIDWORKS naming convention, you have standard, professional, and premium. So let's take a look at the different flavors of this tool. So plastic standard, professional, or premium, we can think about the person who might be using this tool. So plastic standard is meant for someone who's designing a part to be injection molded. Plastics professional is for someone who's doing a lot of the mold design, the actual mold cavity design, the design of multiple cavities, understanding cooling time, runner balancing, things like that. And then premium is for someone who really needs to analyze the part through the injection molding process, and it includes warping and cooling. So let's take a look at each of these flavors. Plastic standard has everything like surface and solid meshing to understand if the part's going to fill, is it not going to fill, are weld lines, sink marks, air traps, something that might cause a potential manufacturing defect. So you can look at all of those things there in plastic standard. All those things have a lot of, the geometry has implications on how those things will be affected in the filling process. So that's why we say plastic standard is for someone who's gonna design a part to be later injection molded. Then plastics professional includes a lot of the mold maker type stuff. So multiple cavities, runner balancing, using inserts and overmolding. How much cooling time is needed to cool this part accurately, right? And then a couple of things like fiber analysis, understanding shrinkage, and then gas injection and valve gates, right? So a little bit more comprehensive, goes beyond just the filling stage, also includes what we call the holding or the packing stage of the process. And then premium takes it to another level by understanding cooling and warpage. Here you're going to actually get not just warpage predictors, but actual results. How much does this part warp? There's warpage predictors in plastics standard and in plastics professional, but they're just predictors and indicators. Here in premium, you get actual results, so you know how much warpage happens to the millimeter. And then you get advanced cooling, so you can understand the cooling channel design through the mold and how it affects the cooling of the part. So that's plastics. The different flavors are standard, professional, and premium. And that's a look at the design validation products. In SOLIDWORKS, you have simulation, flow simulation, and plastics, our structural, flow and heat transfer tool, and injection molding tool.